Hello class and welcome to SPSS assignment number 4. You are going to be working on independent sample t-tests here using SPSS in the general lab for the VPN that you have on VMware. Go into the virtual lab as I will do now and follow along. I've posted a bunch of examples for you, and then I'm going to leave you with one data set for you to work on your own. So please, if you have any questions, go ahead and email me. I think this should be pretty self-explanatory. Most of what I'm going to be doing is sharing my screen and showing you what I was doing. So let's go into SPSS. There was an issue with access to the RWC 2031A folder, but I've contacted IT and they are now allowing access for all of you students enrolled in my class to get to it. So first thing we're going to do is go to Open, Data, and then we're going to, it'll probably be something like, I mean, I'm already in here, but let's say it started off on desktop, right? You're going to do the drop-down menu from Open Data, drop-down menu, and you'll find the P drive, the P for public. Click on the public, and you have all these folders in here. I want you to go all the way to the right. Actually, not all the way because you couldn't quite see it, but almost all the way to the right. Not all the way. Can't see that. Well, you can see the 203A here, but almost all the way to the right, so that you get to RWC-2031A. On RWC 203/1A, double click on that or click on it and click Open. And you'll find Dr. Edmonds' folder. I don't know what's in there. Don't go to her folder. You don't have permission. Go to my folder for ZJ. All right, so in that, you'll probably see this folder here, Fall 2020. This is the folder you are looking for, exclamation point. Double click on it. In that, you'll find that we have the dependent sample t-test stuff that you should have done for assignment number 3. So if you guys haven't done assignment number 3 yet, please do that and use the SPSS software and then that particular file to complete assignment number 3. Again, titling it in the subject, SPSS assignment number 3, and then in parentheses, your last name. I've noticed that a lot of you have not been sending me the SPSS emails in that format, so it's harder for me to deal with grading them, and you guys make it more difficult because I can't quickly sort them into a place to be filed. So please, please follow the format, SPSS assignment number 3, if you're going to do 3 like the last one, and then in parentheses your last name, or in this case we're doing SPSS number 4, so SPSS assignment number 4, and then in parentheses your last name. That's the format that helps my the speed with which I can grade these. Okay, here we are. So we can forget that for now. I'm not going to use this data. Let's go to this one here. There's been some controversy recently over masculinity and femininity. So the question for this research is, this is just an example for an independent sample t-test. Recently, some guy was on the cover of a magazine wearing a dress, and he said he's so masculine. So the question is, are men more feminine or less feminine than females? Is there actually a difference between femininity? So we've measured a variable here, and this variable we measured across both males and females. So femininity measured across males and females. So we just did it on a, I don't know, a Likert type scale, a 0 to 10, 0 meaning 0 femininity, 10 being the most feminine person ever. I don't know who that is, but and then we have over here is our dependent variable. The dependent variable for an independent sample t-test is males versus females. You're either a male or a female, so 1 or a 2. And I define this as, since there's such wokeness these days, this is defined as the number of X chromosomes on your 23rd pair. If you have 1, we're going to call you male. That's the operational definition for this research. Okay. So we've got males, we've got females. The question is, do they differ, right? That's the question in independent sample t-test. Is there a difference between these two groups in terms of femininity? So that is a aspect of someone's gender, the femininity, and we're going to see if they differ on femininity, these two groups, males and females. If they do differ on it, then we're going to claim, and my hypothesis, this is a simple hypothesis, but my hypothesis is that females are higher in femininity than males. So that's a one-tailed test, right? A one-tailed test means that if we find in SPSS a p-value for a two-tailed test, we'll divide that in half, and that will give us the estimate of what our p-value would be. So let's go back to, I'm trying to share my screen now. Go back to SPSS, and we see here, we've got the dependent variable here and the independent variable here. I'm sorry, the independent variable here and the dependent variable here. It doesn't actually matter where they are, if one's on one side or one's on the other. You could switch them and it doesn't change anything, because really when we get to the point later, we're going to see where we put them. Okay, to conduct a independent sample t-test on SPSS, you're going to do a couple things. The first thing is you'll go to analyze and then compare means, right? What we're actually doing is comparing the mean between males and females femininity. And we're asking the question, we're asking SPSS to conduct a mathematical operation. So we want SPSS to say, give me the probability that I would randomly select these two groups. In our case, the researcher has divided it into male and female. We want to say, wow, the sun's really coming out right now. It's raining today, but whatever. What's the probability that we would select from a giant group that doesn't have a difference in femininity, these two different groups, male and female, and that they would have this big of a difference by chance alone, right? That we would randomly sample and get this big of a difference between two groups within the giant comparison group. Okay. So we're going to compare those means, and we're going to go to independent sample t-test. Independent sample t-test, click on that. When we click on that, we'll see that our variables are right here, and our variables are femininity. That's our dependent variable, because we measured it across both groups. So we're going to put dependent variables in the test variable box. You can click and drag, or you can use the handy dandy arrow. See, I can put it in there. Now you don't want to put femininity in the grouping variable, because femininity we measured across both groups and it doesn't actually group anybody. Everybody has some aspect of femininity. Even if you had 0, it's some aspect of it. So we're going to put that to dependent variable. And our grouping variable we're going to use as males and females. Now, when we put males and females here, despite the fact that it's I've readily explained how males have 1 X chromosome on their 23rd pair and females have 2. Although that's biologically true, SPSS has no idea about this. And so we actually have to tell it how we define these groups. And so we'll say, it asks us, how do you want me to identify group 1? And I'll say, well, group 1 has 1 X chromosome on their 23rd pair, and group 2 has, say, 2. That's it. All you got to do is tell them which groups. Now, if this were, say, a different variable, we were saying if you had gone to Disneyland more than 5 times, and so you had a range of scores over here, we would have something like a cut point, and we could have it as, say, 5. So if there was 5 or more times you had gone to Disneyland, you would be in one group, whereas people who had gone to Disneyland less than that would be in the other group. In our case, we're going to be using, you don't want cut points, but I'm just showing you that you could do that. I mean, in this case, I could put a cut point of, 1.01, and then that would do it for us, right? Everybody below that would go into one group, 1, and everybody above that would go into another group, 2. But again, you don't need cut points. So just showing you could do that. Okay, so you've got this group 1 is the 1 chromosome, group 2 is the 2 X chromosomes. Click OK. Now, when I click OK, it's going to run a statistical analysis for us. And what that tells us is what's the probability? That's what our significance level will be, is what's the probability we would get this big of a difference, however big the difference is. It might be small, might be huge. However big of a difference we get between these two groups, SPSS will give us the significance level that tells us the likelihood that that would happen by chance. By chance means that the null hypothesis is true and there's no difference on our dependent variable between these two independent variables. So we're going to be anticipating, looking for the significance value. And if that significance value is, we're going to use the standard cut point of 0.05. If it's below 0.05, we will claim that females have more, depending on if it's in the right direction, if females actually have a higher mean value and femininity than males do, which we're not sure yet, right? Scientists are telling you to question that. If we do the research and we find that females are higher than males and it's a very small probability that this difference is due to chance, we're going to make the statement that females are more feminine or have more femininity than males. Okay. Click OK. Remember, you've got to make sure that SPSS has defined these groups. Okay, we have a bunch of stuff here. I'm going to maximize this window so we can see it. We've got two groups measured both on a dependent variable of femininity. And the first group has one X chromosome. Those are defined as males. I even put it here in the variable description. And there were 28 of them, so there's slightly less. They measured an average or a mean femininity of 3.67, so 3 2/3. Okay, for females, there were 31. See, there's more than the males. This is a unique marker about independent sample tests, independent sample t-tests, is that you can have a different n size for each group. If you remember the video that I told you about how to conduct an independent sample t-test, we utilize S2 pooled in order to make the assumption that these two groups come from the same place and therefore use both of their variability estimates to estimate the standard error of the difference. And we'll see that later in this output here. But just a general thing, there's 28 for the males, 31 for the females. Males are 3.6. Females have femininity of 5.2. Now, you might ask, a lot of you might just say, oh, females are more feminine than males. You don't know that yet. You can't make the assumption that because there's a difference in our samples, that the populations of males and females have a difference. That's why we utilize probability studies, to give ourselves a much better chance of not making that type 1 error of saying there's a difference when in fact it's just due to sampling error, right? I may have selected a really not feminine group of guys and a really feminine group of girls, and it's just sampling error that's caused that difference to be there. So we want to be careful about that, and we utilize probability studies to help us understand that. Let's look at the rest of this. So the first thing you'll see on the independent sample t-test is called Levin's test for equality of variance. Now, I kind of want to tell you to just ignore this. I'm not going to, but if you want to ignore my explanation for it, mute for like the next 15 seconds. Ready? Go. Okay, there are assumptions associated with running any statistical test, and this one just shows us one of those tests for the equality of variance. If this number is below 0.05, you have a problem and you probably can't utilize the rest of it. If not, so our number is not below 0.05, we can completely ignore this, okay? Okay, for those of you who have now rejoined us after I explained something to you that moving on in statistics you might need, but for now you don't, let's continue on. We see we're going to assume equal variances. So equal variances assumed. We can ignore this bottom row. Just completely ignore that bottom row. The equal variance is not assumed. We don't need that for right now. Okay, our t value, the t obtained statistic, is a negative 2.8987. Wow, I can't speak right now. Our degrees of freedom was 57. So 57, you'll notice if we added up 28 and 31, we would have gotten 59. You might ask yourself, well, why is it 2 less? It's because each of these, we do an estimate of population variance, and in estimating population variance, we take a degree of freedom. So that's why instead of n-1 for a t-test of independent means, we're actually taking 2 degrees of freedom, 1 from each estimate of the population variance. And we'll see here the significance, two-tailed, is 0.004. That means 4 times in 1,000. If I sampled 1,000 times, which is a ridiculous number of times to sample things, but I sampled from a population and I measured femininity, I would get this big of a difference between my two groups. If they were this size, 28 and 31, I would get this big of a difference between their means, a negative 1.53. It doesn't actually mean negative. It just means sort of the absolute value of that. I would get, because it's two-tailed, right? So it's in both directions. I would get that big of a difference 4 times. All other times, I would get less big of a difference than this. It would be closer to 0, right? Because that's, if you remember the mu difference in our t-test for independent means, if there's no difference, the average difference between the two groups is 0. Sometimes you'll get a little bit more in one and a little bit less in the other. But if we're doing large groups like this, like 30 on average, you're going to see very little difference between them if they come from the same place. So what this is suggesting to us is that if our p-value here, this significance, is less than 0.05, we're going to reject the null hypothesis. A lot of you were having difficulty with this, and this is something that all statistics students struggle with initially. Is like, how do I know whether to reject the null hypothesis or not? We're far enough into the class now that you should be considering if our statistical significance, that p-value that you saw there under significance two-tail, if that number is smaller than 0.05, we're going to reject the null, unless it said, you know, you had a significance, your alpha level was set 0.01, and in this case it would still be significant. But just generally, if that number is smaller than 0.05, you reject the null hypothesis. That means there's a difference. Maybe there's not, and you might be wrong, right? We've already discussed this. We might be making a type 1 error when we make these claims. When we reject the null hypothesis, we might be making a type 1 error. But in this case, if you do it 1,000 times, you'll only make 4 errors. The rest of the times, you'll have correctly judged that these two groups are different. So have confidence if your p-values are very low. I am very confident that females have higher femininity than males right now. That's my confidence. And you see here our calculated standard error of the difference. And I want to reiterate what this is. This number is like a standard deviation for the distribution of the differences between means. And it really says to us, if we got two different groups, males and females in this sense, but if we just did any two random groups from this population, remember, we're treating them as a single group when we're calculating this number, because we're using S2 pooled. Actually, we're not. SPSS did for us. But in this sense, we expect the two groups to be different on average by a standard deviation of 0.5, or half of a point of femininity, if there's no difference. In our case, we saw 3 times that, right? 1.5. We saw 3 times the difference here. So that is showing us why it's so significant, because this is what we expect, this is what we observe, and that's very different. So we're showing that males have less femininity than females. Now, I've made it an egregious example, obviously, and I made a silly one, poking fun at the wokeness of whoever that Jonas brother wearing, or Harry Styles, I forget who did it, but some guy wore a dress and was like, look at me, I'm so feminine and I'm a man. Okay. But yeah, females are more feminine than males. If you're curious about talking about gender and you're really into this, go watch my video with one of my neighbors who is a professor of women's studies, and we discuss gender. And in that video, we talk about the idea that we should probably move gender from the sex category to the personality category. Okay. So you guys don't think I'm being, I don't know, is there a woke thing for not believing that gender is different from sex? Is that somehow illegal yet? I don't know. Anyway, we've just proven with my fake data that females are more feminine than males. Let's move on to another example. So I made up a bunch of examples. I wanted everybody to be able to look at this and really understand. So we're going to go through several examples and find statistically significant differences between two independent groups. Remember, these groups have to be independent, and I use males and females as different as they can be. And what we'll see is that in the next ones, these groups are also independent from one another, and we'll ask the question, are they statistically significantly different? So I'm going to open up a new data set, and I want it to be, so some of my family lives in Michigan, and they seem to be, I think that they have less anxiety about COVID than we do here in California. And so what I did is I went to Michigan, and I measured all these Michiganders. That's actually what they call people from Michigan. These Michiganders, I measured them, and I found all their anxiety levels for COVID. I said, how anxious are you? Scale of 0 to 40 on anxiety about COVID. Number 1 are Michigan, and number 2 are California. There's this, I just arbitrarily made them 1 and 2. Sorry. If you wanted to be number 1 Californians, sorry, you're number 2 here. Okay. Michiganders, these are their anxiety levels of COVID. Now, you can't just glance at that and go, well, it's totally different than this one. We don't know that it's different, but I measured those two, and now we can use SPSS. We can use this software package to tell us, is there a difference between the anxiety that Michiganders have about COVID and the anxiety that Californians have about COVID? We don't know who's more or less anxious, or even if there's a difference. I don't know. I think that there might be less anxiety in Michigan, but maybe I'm wrong. So I don't have any idea, and I'm going to do a two-tail test. That two-tail test is if you don't have any particular notion, like I clearly had a particular notion that females had higher femininity than males in the last example. And so that's why we did a one-tail test. Now we'll do a two-tail test because I don't know. I don't have my finger on the pulse. Sorry, that's how you do it. Finger on the pulse of anxiety for COVID in Michigan, nor in California. So we're going to do a two-tail investigation, find out, is there a difference statistically between Michiganders and Californians concerning their anxiety on COVID? And I have the data here. Number 1 is Michigan. Number 2 is California. So we're going to do that exact same thing we did it before. We're going to go, oh, you know, I need to get rid of the old outputs. I'm just going to get rid of these old outputs here. Don't need it to save any of that. Okay, here we go. Whoops. I think I closed the wrong one. Here we go. Again, Michiganders versus Californians. And this is the one I wanted to close. No, I don't need that one. This is what happens when you get distracted. I have so many examples here. I don't know which one I'm focused on. Okay. Analyze. Compare means. Independent sample t-test. And again, we have that same setup where our two variables, we have to decide which of these two variables is our dependent variable and which is our independent variable. Our independent variable is always the one the researcher is implementing. People have anxiety versus COVID. I'm not implementing that on people, but the arbitrary distinction I'm making is I'm assessing if there's a difference between Michigan and California. So I'm implementing the difference of Michigan to California. I'm not implementing that people have anxiety over COVID. So anxiety, we measure both in COVID, anxiety over COVID, we measure across both groups. So that becomes our dependent variable. Anxiety over COVID is our dependent variable. We can either click and drag or use our handy dandy arrow. I like using the handy dandy arrow. For our dependent variable goes in the test variable box. Now, this Michigan versus California, I've used their postal abbreviations here. In case you didn't know, MI is not like Missouri or Mississippi, both of which start MI. It's in fact Michigan. So if you're mailing things to Michigan, it's MI. Okay, MI versus CA. Now, SPSS doesn't know the postal abbreviations. We have to tell it which one's which. And we've decided that Michigan is 1. So we're going to say group 1, Michigan is 1. And group 2, California is 2. Now, look, if I had all, let's say I used, let's say in the data, I had all 50 states, anxiety for COVID for all 50 states, but I just wanted to compare Michigan versus California to make some statement or make some claim or see how federal funds should be diverted for helping people with their COVID anxiety. And I just wanted to compare 2 states. I could then take an entire data set that had all 50 states. You know, maybe it's listed by when they joined the union. So, you know, Alaska and Hawaii would be like 49 and 50. And now that Biden's in, Puerto Rico will be 51. But what we see is I could go and easily select those 2. I mean, there wouldn't be number 1 and 2. Michigan wouldn't be 1. California wouldn't be 2. But in that thing, there would be states 1 through 50. Whichever one was Michigan, I could tell SPSS use the ones that have this number, and then whichever one's California, use the ones that have that number. And so that way you could do from a large data set an independent sample t-test. All right. Anxiety over COVID mission. Okay, so we've told it which one's which, and we will now click OK. See what happens. Is there a difference? Okay. There was 25 from each. Fine. Equal samples. Michiganders had 18.76 anxiety, and yet Californians had 20.04. Okay, so when you see that, just like the last example of femininity in males and females, we saw that there was a difference, and I caution you, don't immediately think that this is a statistically significant one, because it might not be. And in the case of femininity, it was that males did have less femininity than females. But we don't want to always make that assumption, because differences exist in groups. When we sample from groups, there's going to be variability of scores. And sometimes the variability that we see is just due to random sampling. And that sampling error is what it's called, is what's causing the difference, not a difference because these 2 groups come from 2 different places or 2 different populations of whatever dependent measure we're using. This difference might be just due to the fact that we only had 25. Let's find out. Here we go. Again, Levin's test for equality of variance. We see it's not below 0.05. Ignore. Here we see that our t-value is much smaller than the last example we had. Our last one was like 2.987. Now we have negative 0.628. Again, how you calculate that is you take the mean from group 1 minus the mean from group 2. That's shown over here, a negative 1.28. And then you compare that to the mean difference, which you would expect from the mu population, and that's a 0. And you divide that by our standard error of the difference, or we see over here 2. We expect 2. We literally expect almost the same amount we're seeing. We actually saw less difference than we would have expected on average between 2 groups. So you hear that? We expect to see a mean difference average between 2 groups that are randomly selected from the same anxiety about COVID population to have on average a difference of 2. We only saw our 2 groups, Michigan and California, with a 1.28. Well, if we expected to see 2, we saw less than that. It doesn't bode well for us to be able to reject the null and say that these 2 groups of people are different. In fact, we can't. We see here the significance is 0.533. What does that mean? Well, it means half the time that you select 2 groups, half the time you select 2 groups, and you randomly select 2 groups from the anxiety of COVID population, you're going to get that big of a difference or more. That this is the normal amount of variability we see in making 2 groups of 25 sampled from the anxiety of COVID population. So because this number is so big here, 0.533, that happens more than half the time that you sample with 2 groups of 25 from the population of COVID anxiety. We see that big of a difference that we saw, negative 2.8 or larger, more than half the time. So we can't claim that these two groups, Michigan and California, are different in their anxiety because this number is not below 0.05. It's 0.53. That's half the time. Below 0.05 means it only happens 5 times in 100. This happens more than every other time. So here we have an example of where there is not a statistically significant difference between Michigan and California on their COVID anxiety. I do, however, still want to compete with Michigan. So I'm going to give you another example. Here's my next example, okay? My next example is who's better at statistics. So I convinced a professor in Michigan to give the exact same test I give to you guys. And that way we'll have a dependent measure of your statistics scores or your final grade, right? See how you guys do. And I convinced that professor to use all the same metrics. So we're getting a one-to-one comparison. And now we're going to compare you to the students in Michigan and see how your grades are compared to them. Just because I'm hopeful, I think you're going to do better than them. So if you do better than them, we should see a significance value below 0.05. And remember, if we see one that's not quite below 0.05, it's a two-tailed test. But I think you're better. So if I think you're better, then it's a one-tailed test. We're going to divide that significance level in half to see if we can get below the threshold of a 0.05 and reject the null hypothesis that Michiganders and Californians are the same, right? That's the null hypothesis, is always that they're the same in terms of their ability in statistics. That's my belief, is that you're better. So let's go investigate it together. And again, these files are all available for you. All these 3 example problems that I've given you, you can all open them up on this folder. This folder is now available to you. And we'll be able to check to see how you guys did. Okay, we've got, again, Michigan's 1 and California's 2, just the same thing. And look, there's so many students here. There's no way you're going to eyeball 86 scores and be like, oh yeah, that one group is better than the other. And so what we're going to do is we're going to utilize an independent sample t-test to ask the question, is Michigan worse than California with regard to statistics? I put the variable of test score. Remember, we use the same test in both states. So that's our dependent variable. But Michigan and California are different, so they go in the grouping variable. Whoops, I forgot to use my handy dandy arrow. Okay. SPSS does not know the distinction between groups of people. That's something arbitrarily that I am doing here as the researcher, as the experimenter. Therefore, I need to tell SPSS how to define those groups. And again, as simple as 1 and 2, with all the caveats of if Michigan wasn't 1 and California wasn't 2, we would have to tell it which ones to get from a larger group. Click OK, and let's see what we find out. It says that the Michiganders, there were 35 students who took statistics. They averaged a D plus, 69.17. And the Californians, the 51 of you got a 74.5294% average. Now that's great, right? But we don't know if this like around a 5-point difference is a significant difference. As we saw before, we thought that Michigan and California were different in their anxiety for COVID because there was that 18-20 split, but it turned out not to be a significant one. We found out that it was just a normal amount of variability because we looked at the data. We saw how much they varied. We estimated population variance from those two groups. And now we're going to do the same for test scores and statistics and see if there's a difference between these two groups. So our T value, Levin's test for equality of variance, it's not below 0.05. Ignore this entire box, this whole F significance box. Let's go to our T statistic, a negative 2.01. Hey, that's pretty big. And we have degrees of freedom is 84. So that's a large sample. We have big sample here. We see that our significance two-tail is even below 0.05. Now I said one-tail test because I thought Californians were better than Michiganders. At statistics, that is, not at like niceties. They're really, really nice there. Okay, 0.048. If we divided that in half, we get like 0.24 or 0.024. So that's way below our threshold of 0.05. Even this number is below 0.05, right? It's 0.048. It's smaller. Even if we had done a two-tail test, we didn't know who, if there was a difference. We thought there just might be a difference. But I claim that you were better at statistics than the Michiganders. So that being said, we get to claim now, because you guys had a probability or significance level, the p-value was 0.024. That's well below our threshold of 0.05. And so we're going to claim that Californians are better at statistics than Michiganders. Now, I want you to go out and prove it by doing SPSS assignment number 4. And here's how you're going to do it. You are going to utilize this last data set that I have not shown you yet. In that fall 2020, this is the folder you're looking for, exclamation point. I have a question. Here's my question. You know, people have been pretty depressed about this whole election thing. I don't know why. I'm not. I'm happy. But they've been pretty depressed. You know, half of America's on Team Trump, half of America's on Team Biden. Some of us are independent thinkers. I think that both of those men are horrible, horrible selections for our country. But it makes us depressed. And the question is, are Republicans and Democrats different in their levels of depression? That's the question. Now, I recorded this after the election, so we know Biden is winning and we know Trump is losing. The question is there a difference in depression levels based on political party affiliation? So I've measured a whole bunch of Democrats, a whole bunch of Republicans, and I asked them their depression levels. Data that I just showed you. Actually, I didn't show it to you yet, but it's this data here. Depression of Republicans versus Democrats, independent sample t-test. This is the data that you're going to use to complete assignment number 4, SPSS assignment number 4. You're going to run through, I've given you 3 examples here, significant examples, not significant examples, one-tail test, two-tail test. You're going to have to figure out, is it a one-tail test or a two-tail test? And is this a statistically significant difference? We'll use 0.05 as our threshold. Is this a statistically significant difference? And you're going to have to run that on this data that I have here in this folder. This is the depression of Republicans versus Democrats, independent sample t-test in parentheses. That's a .sav file. Now, I need you to go ahead and run that. Go ahead and run that data. Find out if there's a difference in depression levels between Republicans and Democrats post-election, and then try to explain it, right? Explain it to an 8th grader. Say, here's what we found, and this is either expected or surprising in the body of your email. Thus far, I haven't graded your SPSS assignments thus far, but I see them as they come in, and sometimes I see the little explanations that you guys use. And many of you are doing a good job, but some of you are forgetting when we reject the null hypothesis what that means. If our statistical significance, the p-value that's in that box of significance on SPSS, if that's lower than 0.05, we're going to reject the null hypothesis. And that means it's very likely that these two groups we're measuring are different. So there is a difference. We reject the null hypothesis. That means we think there's a difference. And there's a low probability that we're wrong about that. If we fail to reject the null hypothesis, let's say that significance level, the p-value in the significance box in SPSS is bigger than 0.05, we say we cannot make the statement of our research hypothesis is true. So we say there is no difference between these two groups in the dependent variable that we measured. I hope that helps. I look forward to seeing your SPSS assignment number 4. Complete this by going on the SPSS software, doing that Dems versus Republicans depression after the election, and answer the question. Send me the SPV file alone. That's the output. Remember, I'm giving you the SAV, so I do not need the SAV file from you. Many of you have attached the SAV file in assignment number 3. Sorry about the difficulty getting you that data, but you now all have access to it, and so you can do assignment number 3 and assignment number 4. I have a lot of people telling me that they're having anxiety at this point in the semester about how they're doing in the class. And I want you to stick with this. Please stick with this. The SPSS assignments, these are pretty easy. And if you're having problems with it, let's get together and talk about it and make sure that everybody is on the same page, because I want you all to be able to do this. And this is a big part of your grade, and it can really help you. Let's say you're in the 65% on the test scores, but you're getting 100% on the SPSS, right? You're grasping how to utilize this software and how to interpret it and tell people about it. You're going to pass the class, because this is a large chunk of your grade is the SPSS assignments. And I want you to put your best foot forward. The due date for this is going to be November 30th. So have assignment number 4 in by November 30th. Any questions, email me. And if you need to, we can Zoom. Looks like nobody joined me on this. Oh, somebody did. Toad, you're on here. Hey, really glad you're on here. All right, I'm going to stop recording. Toad, I'll stay on with you for a second if you had any questions. And appreciate you guys for sticking with this class. You are total troopers. I am impressed by you, and I'm proud that you're continuing to do a difficult thing like taking online statistics.